Hey everyone, how are you all doing? Welcome to TECHPODS, your go-to podcast for something spectacular. I'm Alicia, your host, and today we'll be entering the vast world of technology with me. Today, we have our very own Vice Principal and the Professor at the Electrical and Electronics Department, Dr. Chikku Abraham, with us to enter into this vast world of innovation. So, sir, reflecting on your career, why did you change from industry to teaching?
Actually, that's a very good question. I never knew after my graduation that I'll be a good teacher. So I switched from industry to teaching in 2001. Now this is my probably 22nd year of teaching. And now I understand that teaching is my passion.
Oh.
And if you ask specifically why I changed, I had some family issues wherein my mother was not well. And I was working in Indonesia and then I had to come back. But I never thought I will be into teaching. But now I enjoy teaching and I feel that teaching was my cup of tea.
Thank you, sir. So, as an educator, what do you find the most effective for creating a learning environment that's very engaging? Because most of the times teachers will be like, oh, you guys have very short attention span. So how do you think that can be corrected?
If you don't give me the constraint of 8 hours for one module, what I would suggest is teaching will be effective with case studies. So mostly of late I teach power electronics. It's a very good subject which you can really interact with the students, make them think and give them real life examples and ask them to give their views on it. But on the other hand, with the university curriculum that we follow, in 8 hours I have to finish one module. So maybe that may not be the right method to complete the portions. So what I try is, in between I blend. And maybe I have to take 1 or 2 lectures more. But I try to at least introduce some case studies. But more case studies would be engaging.
Okay.
That's my feel.
That's fantastic. So, sir, you've been working for so long and you've seen so much students come with so much batches. Like every year a new batch would be there and every single batch would have such a different vision of the world. So how do you change yourself with the changing generation of students?
If you ask me in 2024, my son is now almost 19 years. My daughter is 17. So I see all these changes in my home.
Oh.
So the best part in the last 18 years or 20 years of my teaching is I see from my home how they change, how their friends change, how they become more digitized, and how I should appreciate their freedom. So the same thing I see in the students in MITS also.
So you change yourself with comparing to your
children. I understand from that perspective what they think, and so I think right now I'm comfortable.
So I asked you earlier also, but what is one of the best memories that you had with one of your students or a batch throughout your career?
There are many such good experiences. Still, I have a student whom I taught in 2006. I started my teaching career in 2002. So the first batch of that engineering graduated in 2006. And she still wished me for all Teachers' Day. And she is with Infosys now. So probably her son is now 10 years old.
Oh.
And she still keep in touch with me and always tell, sir, you only made me now to where she is now. And I remember she didn't want to study engineering at all. So her mother was forcing her to study. She never enjoyed the first year. And then her mother took her to me. And then at that time I was very young. Maybe I would have been 4 or 5 years elder to her only.
Oh.
But some things what I told inspired her. And from there on, she started studying. She was in IT. She was in a branch called IT, and she really did well, and she always wishes me on my Teachers' Day and tells her, "You inspired me, and that's why I am now." So 20 years, 22 years, a student whom you taught, still keep that.
Must be very inspiring.
Yeah, so it's very inspiring. There are many examples. Just one example, quick example, which I thought I'll share.
Thank you, sir. So, sir, we are here for talking about the patent you just received. So, would you like to walk us through the invention works, your buck-boost converter? How does it work?
Yeah, so this particular patent is for a converter which has no inductors. So normally, we have in all the converters the buck boost or the buck boost, we have inductors. In the converter that I got patent, this gives a single circuit can give different modes of voltages at the output from two voltages in the input. So let's say V in 1 and V in 2, you can have a combination of adding that voltage or multiplying that voltage or even inverting that voltage at the output without an inductor in it. So you call such kind of circuits as switched capacitor circuits or switched capacitor cells. So you have only switches and capacitors. So the advantage when you take out the inductor is the size of the converter comes down and you can pack, energy density increases, but the major disadvantage is you can't use it for very high power. You can use it in the watt range, but there are many electronic gadgets that need only that much of power. So the advantage is one single circuit can switch to many output voltage configuration without the use of inductor. I had around 5 to 10 combinations at the output voltages. So for this work, I got the patent.
Okay. So for understanding this in a much more easier way, could you talk to us about how this can be applied in real world applications of this invention?
If you ask me, if for anyone to understand, in our computers, you have 3 modes, active mode, then sleep mode.
Yes.
So when the system goes to the sleep mode, you need only less voltage.
Yes.
So if you can have a converter which can be used to switch between different levels of voltages according to the truth table or the logic circuits or the things that we give, then it becomes easier. Yes. So one good application could be the computer, when it is in the active mode, it needs 1 voltage. When it goes to the sleep mode, it needs another voltage. So this converter can be a good solution for it. Plus, if you see the size and the form factor of any circuits or even the laptop, it is coming down. So there, a converter which can cater to all this at the output, but at the same time, if you can reduce the size of the converter, then that becomes more compact. So one simple application can be like
in
what
the
I...
laptops.
Yeah.
Okay, sir. So I have to ask you about it. Of course, this invention would have required so much research. And when we, from outside looking in, research is such a big term. Like everybody would be scared about it, and it needs so much dedication and tenacity to do that. So what were the obstacles you faced during your research, and what was your motivation to overcome them?
In any research, you will face a lot of obstacles.
Yes.
And obstacles are always part of any research. Probably my research took, I did part-time. I'm talking in the PhD perspective. So I did part-time, it took around 6 years. So 6 years is a big period. You have to manage your workplace, your family, then your research. So it was a big challenge. First 2 years, you don't figure out anything.
Okay.
Even you don't know what problem you are going to attack. And sometimes you attack a problem and in between you understand that this has been done by many.
Oh.
So then you will have to halfway stage, you will have to drop it. But all those are learning experience, and somewhere you will get a spark wherein some eureka will touch. So in my case, I was attending a conference, a workshop, rather a conference. It was a short-term workshop in IIST Trivandrum, Indian Institute of Space Technology Trivandrum. So there I was listening to a professor. So he was explaining a circuit for another application. So from there, I correlated it to my converter. So that was the first spark which I got. Yes, this is a good problem and I have a solution to it. From there I started this buck boost inverted switch capacitor converter. So the simulation, the mathematical modeling, everything was difficult. So there was a stage when you need to publish papers. So when I wanted to publish papers in reputed journals, you need to have in general 3 aspects of it. One is you need to have a good literature survey. Then you need to have your circuit explanation, the working principle of the circuit, and very importantly you'll have to model it, the mathematical modeling. So that mathematical model is nothing but certain equations. So those equations, there are a lot of approximations. You will have to, there is no single text which will give you that equation. So for your converter, you will have to model it. So you will have to get reference from different places, that is fine. And I got stuck in between with my modeling. So at that time, I came across through a paper from a researcher in Israel. His name is Michael Ebzelman. So I just thought I'll put a mail to him and ask how he derived this in his paper. So I just put a mail with my converter and what all I did. He was very kind enough. On the 3rd day, I got a 3-4 page PDF. He helping me figuring out where all I went wrong and where all I should correct it. And then that was like solved at that time.
Yes.
So from there, I could go very fast. Then the experimental part was okay because the mathematical modeling and simulation, it did agree. So then I can definitely go to my experimental part. So sometimes, you should be a bit fortunate and God should be there with you. So for me, always Michael Ebzelman was my angel, helping me out. Yeah. So there are a lot of obstacles, but at the end of the day, somebody will be there to whom you don't think will be helping you. So keep on knocking and keep on trying. So
one of the doors will open for you.
Doors will open for you.
Thank you, sir. So I should ask this question. In your background in energy systems, how do you see renewable energy shaping electrical engineering?
Renewable energy definitely is going to be a major share in the electrical generation, distribution and transmission. As you all know, the fossil fuel, the hazards of fossil fuel, not only that it is depleting, but the kind of global warming and the climate change that we face now.
We are affecting it now.
We are affecting it now. So major share has to switch to renewable. And you can't say which renewable energy would be promising. It depends on the geography. It depends on where, for example, wind energy will be good where you get decent wind. Solar would be good where you have enough sun. But definitely the mix of renewable energy will increase, and with the advent of power electronics and the way in which power electronics have advanced, you have a lot of solutions for all this. So it is not just the usage of renewable energy, but the associated circuits, the associated power electronics that will help to efficiently harness the renewable energy is what has made promising in the recent years. And it is growing. So definitely renewable energy is going to have more share down the line.
Yes, sir. So I am an AIDS student myself, so I would like to know how AI and machine learning would be changing power electronics in the near future.
I'm sorry, I have less idea about artificial intelligence and of course data science. Data science definitely we all hear it as a branch of science, but all through we deal with data and then from the data only. So but the machining, the artificial intelligence part of it can probably help us to monitor things better and take decisions faster and quicker, So in that way, I think AI would penetrate in this. But I have not done much work of AI into my research. Maybe I have to explore more.
Okay, sir. So, can you explain the technical challenges that you faced during your research period?
I think I explained almost, yeah, almost.
So, about like your the researcher from Israel who helped you.
Yeah.
That was the only technical challenge?
No, technical challenge, I had a lot of technical challenges. I was telling, in a research, sometimes you get stuck and from there, technical challenge means, to select the right switch, and the switch in the experiments getting burned off, money flowing like anything.
Of course.
So all that was a learning experience, you burn a lot of switches and learn.
Like Thomas Alva Edison did.
Yeah, but at the end of the day, you could verify that the circuit is working well. But of course, it's only very crude. So like when I went for my patent, there are 3 stages in a patent. One is the patent, there's a search first, and then the patent has to be published. So you file a patent, then after 18 months you publish the patent. Then after that it takes quite a long time to get it awarded. So in between there is an examination happening. So it's like in a court, you have a judge and you try to defend.
This examination is international?
You will be allotted with an examiner whom you do not know, but there is, like our university, there is a controller of examination, there is a person who is assigned, and they will assess your work, and then they'll send you similar patents and ask us to read and justify. So there, 2 of the patents that I got was, one was a similar work done in Intel, and the other one was from I think a company called Infineon. It's a semiconductor. So they also probably make converters. And so I was a bit happy that such giants are also
doing the same research as you are.
Yeah, they were also researching in, probably I would put the other way around. I have read those, so I could get a variation out from what they have done.
Yes.
So there was a potential in an international way, but I'm not sure whether it will get commercialized. But in my laboratory experience, what I'm happy is the mathematical modeling and the simulation results and the experimental results, it worked well. So that gives a confidence.
It does. So could you say something for the aspiring engineers in electronic engineering, electrical and electronics engineering? Some words from your youth, anything?
As a teacher, I would be very happy when one batch of students, where they sat for placements. So they asked which subject. So normally it's a question, which subject you like the most in that particular semester. So that's a common question that sometimes you may get in a placement. So in a batch, there were around 5-10 students who told the subject I liked was power electronics, and I teach power electronics. I have written texts also on it. So at the end of the placement, few students got in. So the HR head was searching with the placement officer who taught power electronics. So he said a faculty called Chikku sir has taught it. I wanted to meet him. So this HR person called me and told, sir, you are a good teacher because many students in that batch came and told the subject that they love is power electronics. So as a teacher, you become so happy when the students say that this is the subject I liked, and for the placement also, and they could answer questions also. So the kind of examples that I told about the case studies. Yeah. So sometimes, the kind of examples that stick in the mind of the students.
Of course it does.
And for placement, sometimes, they ask some questions and they quote these examples. And that examples are relevant sometimes in that scenario. So what I feel is, there is little, boundary with any branch. Especially nowadays, when I graduated, probably electrical engineering per se would have been an electrical engineering standalone. But now you ask me about AI in electrical engineering. That's the way in which things are changing. Yeah. So if you're good in any branch, be it civil, be it mechanical, so I always tell an example. differentiation and integration you study in 12th, right?
Yeah.
Okay.
Yeah.
A civil engineer use differentiation and integration. Electrical engineer use differentiation and integration. Applying differentiation and integration to that particular problem. So it's not the problem that matters. You understand the problem and you know the mathematical tool that you studied and you apply it there, which means you will be able to solve any problem because you have that skill to understand the problem and you know how to apply the mathematical tools that you studied, or your differentiation, integration, differential equations for that matter. In all the nature, you model many things, differential equation.
Yes,
So a person who can understand the real life problem and a person who can use his fundamentals in math to model that, be it any branch. So I think we should be trying in that way.
Yes, sir. Having a interdisciplinary.
And you should be understanding the problem well, and then you should be researching enough to model that. So you can't say I only learned computer science, so I don't know the other thing, because those days are gone now.
Yeah.
So you should be good in your fundamentals such that you can apply that. And if you ask me, maybe 5 out of 10 samples that you take anywhere, most of them may not be working in the branch that they studied.
We
Right.
hear that every single time. Every teacher will say that.
Maybe five. It could be more than 5.
Yeah.
So it's all about, you understand the concepts and you want to apply it.
In different ways.
And there are certain skills that you need to take along with, especially, you should be having good interpersonal skills. You should be able to work in a team. You should be able to communicate well. You should be able to write decently. So all this are flavors I think the student has to get, so that you become a totally successful individual in your domain. And I always would say, from the academic perspective, if you want to be a real good engineer, your studies start after 4 o'clock till 2 a.m. I have quoted this many.
Even I've heard it
You
before.
have heard it, and that is true, I guess, because you can't do everything in your college timing.
Yeah.
So anyone who spends more time, you should be able to spend 10 to 11 hours a day along with your academics, and then enjoy watching some films and music another 2-3 hours. That's fine. Sleep for 6-7 hours,
Yes, sir.
but not without doing something a day. Don't sleep.
Of course.
Quality. Yeah.
So that was the final question to you, but I would also like to ask you something else. So what do you want to tell the people who are listening to this podcast, and what do you want to tell all these people who are interested in technology and they want to grow, because that's the kind of people who are listening to this? So what do you like to tell them?
For me, a person who choose engineering, some of them choose because of their passion. Some of them choose because their parents forced. But probably for me, if I see, engineering would be a good choice, or technology would be a good choice for you to settle in life early. So 17, you are 12th and 4 years of engineering, 21, you are into a good job, and if you want, you can study further. But if you feel that I'm happy, I want to work more, then you can start settling in life at 21, 22. Maybe a doctor, after MBBS, MD, then it takes quite a long time to settle in life. Maybe an advocate, he needs a lot of practice and things like that. A chartered accountant. So for me, if you really love engineering, and if you really have that flavors of engineering, I think you can grow to any extent, like we hear about Satya Nadella or Sundar Pichai.
Yes, sir.
All those,
That's always the motivation.
motivation. So they become finally the heads of the companies.
Yes.
So technology in that way, you can always reach to any ladder.
Yes.
Top of the company, and of course, technology is driving us in helping solving many
many
real world
problems.
issues. So
Yes, sir.
technology is fascinating,
Yeah,
but one should have a passion for it.
of course. So that was the final question we had to serve, and I guess it's time to wrap up. Thank you everyone for joining us on this episode of TechPods. Until next time, see you. Bye.
Thank you.